Hello all and welcome to this video lecture on decision analysis, and now we start with chapter 2 called Eugene Equally Brisk Synchronized Rain Gear. So this is a continuation for the Brianna Brisk case. Now we consider Brianna's spouse Eugene. And in this first section we have this similar thing that as we had with Brianna Brisk. So we have the problem description, then the decision matrix and decision rule, and finally the optimal decision. So Eugene Equally Brisk is Brianna Brisk's spouse and colleague. He walks also every day to his office with Brianna, and Eugene's decision problem is the same as Brianna's, that is what gear to use for the walk, and three alternatives. The alternatives are A1 normal gear, A2 umbrella, A3 raincoat. And the Eugene scenarios are almost the same like Brianna's, but now in addition to dry, rain and calm, rain and wind, there is so warm weather. And okay, it's well known that it's never warm when it rains in Vaasa, so we have the following scenarios. So I use here three sub-indexes. So S11 is dry and warm weather, S12 is dry and cool weather. So the S1 is split into two scenarios. So this was just S1 for Brianna, but for Eugene it's S11 and S12. And then S2 is the same as Brianna, rainy and calm weather, and S3 rainy and windy weather. And now, unlike Brianna, Eugene is not weather forecast critical. So he is very interested in the following probabilities. So probabilities for the scenario. So for example, P11 is the probability of S11, that is the probability of dry and warm weather after the working day. P12 is the probability of scenario 12, that's the probability of dry and cool weather after the working day. And P3 is the probability of S3, which is rainy and calm weather after the working day. And finally, P3 is the probability of scenario 3, S3, that's the probability of rainy and windy weather after the working day. So these probabilities have to be figured out somehow, and okay, let's get back to this later. So before that, let's have a decision matrix or reward matrix, and just like Brianna, Eugene bases his decision on subjective comfort. So Brianna used subjective comfort as rewards, so does Eugene, but Eugene is a little extremist. So everything is for Eugene very comfortable, that's value 1, or very uncomfortable, that's value 0. So the comfort matrix, so this again took some time to figure out what it is. So the comfort matrix or reward matrix, decision matrix for Eugene is the following. So let's analyze a little bit what are the numbers that I have chosen there. So again, I emphasize there is no mathematical formula that gives you the decision matrix. You have to figure it out somehow. So this requires some creativity. So normal gear is comfortable for dry weather, so dry and warm 1, dry and cool 1. So remember, now we have 4 scenarios, and for rainy it's very uncomfortable, so zeros. Umbrella, it's uncomfortable to carry in a dry weather, and in the wind it doesn't help, so it's uncomfortable there also. So rain and calm is where it's useful, so then it's very comfortable then, so that's number 1. And finally, raincoat. Raincoat, if it's dry and warm, it's not very nice. If it's dry and cool, it's okay. I mean, you don't sweat so much in it. Rain and calm, it's kind of not so nice at all. Of course, it's, I mean, here it says the normal gear and raincoat are both in rain and calm as bad. Maybe this should be 1, maybe not. Now I have decided it to be 0. So, and finally, rain and wind, rain cold is the best choice, 1. Okay. Let's have the same thing for Eugene as we had for Brianna. So the intuitive choice based on his feelings, and Eugene thinks like Brianna, A2 umbrella is a good choice. So here is this matrix. I've used the abbreviations here so that the margins don't, so it fits into the margins, and then the like intuitive choice is 1, the umbrella. And now again, just like so now we have this decision matrix and intuitive decision, just to check whether this will be the same as the analyzed decision. And just like Brianna, Eugene wants to understand the intuitive decision, its background and values. And so for this, Eugene has to decide how to react to uncertainty. And Eugene decides that he values uncertainty by using expected values. So what is expected value? It is the value of AI, so alternative I, is its probability weight sum or expected value. So VI, EV like expected value as a superscript. So I take a sum over J. So the rewards are IJ. So I is fixed here. So we are looking at the alternative I, and then different values it can get for J for different scenarios, and they are weighted with the probability of the scenario. So this is the expected value rule for decisions. And here is a little bit of discussion about the expected value. So if we take this AI to be a random variable that takes the value Rij, if the scenario as J happens, then this expected value is really the expectation of AI. So this is the probability formulation. So this is AI given Sj happens with the probability of Sj, and this AI given Sj happens, this is the reward Rij, and the probability of Sj is Bj. Okay, now to use this rule we need the probabilities Bj, and this is in practice in many situations this is very difficult to find out the probabilities what they are in different cases. Here we just assume that they are given by the weather forecast, simply that the P11 is 5%, so this is the warm and dry, warm and dry, then cool and dry P12 is 45%, rain and calm 25%, and 25% also for the last choice, which was rain and wind. Okay, so for example in these probabilities, the probability of rain is scenario 2 and 3, so it's 25% plus 25%, that's 50%. Probability of dry and warm was this 5% here, and probability of rain and calm is this P2 25%. And now we can calculate the values, expected values for all these choices. So this is a bit cumbersome, but it's doable. You just calculate, for example, EV expected value for 1. So 1 was the first row here. This one, which is the normal gear, so 1 times the probability of S11 plus 1 times the probability of S12, and then 0 times these probabilities. So it's calculated here, 1 times P11, 1 plus times P12, 0 times P2, and 0 times P3. It's 5% plus 25%, that's 50%. In the same way, you calculate for the next row and the last row. Okay. And now, so these are the values, expected values all these decisions and combining this to a decision matrix. So this here tells all the story that we have had here so far. So here's the gear A1, A2 and A3. Okay, again I use the abbreviations because otherwise this would be too wide to fit into this page. Then I have scenarios S11 and in the parentheses here I have the probabilities S12 and its probability, S2 is probability and S3 is probability. This is the decision matrix that we have decided. Again, this was the creative part of this analysis. Then this was the intuitive choice, so V int 0, 1, 0, so it's just 1 for the intuitive choice and zeros for all else. And then we have the expected value choices, so these numbers here are these numbers. V expected value 1, V expected value 2, V expected value 3, so they are 50, well actually 20, 0.5, 0.25 and 0.7. And what does this show? This shows that the Eugene's feelings-based choice A2 umbrella is not consistent with this expected value choice A3, which is actually a raincoat. Okay. So what happens now? That's an interesting thing. So Eugene is left with two choices, either stick with his intuitive choice or change the choice to a maximal expected value choice, which is then A3. And Eugene decides to be consistent with the expected value and change his choice to A3 raincoat. So this was the problem description, reward decision matrix and decision rule with solution for Eugene. And this was all for this section. See you in the next video lecture. Bye.